Alright, I'm starting videos for the second activity for next week, and I'm kind of going out of order because I'm starting with math. I've decided we're going to have fireside chats. Back in the 1930s, President Roosevelt, I believe, had fireside chats because we didn't have internet, we didn't have TV where everybody could watch a speech necessarily. Had radio, I think that was about it. And they didn't have town hall meetings like we do today, I don't guess. But anyway, we're going to have a fireside chat that has to do with math. We are skipping a couple of pages in your book, and it's okay because I've already looked through the skills and I know which skills we need to hit and which ones are kind of review. But your target today is I can recognize 1/3 of an object or group, and I can apply logic to concepts of elapsed time. Not my favorite subject to teach, elapsed time, not my favorite part of math, but we'll hit it a little bit. We're going to just do a few of the review problems that I have on the paper. If you're not doing the video, you may get to do all of the review, but we're just going to hit a little bit because my math tends to run over. So the first thing, if you've got your pencil and paper or your whiteboard, I want you to do 4,368, take away 957, and then pause it, get your answer, and then you can go over your answer compared to mine. So when we look at the smallest place value, it's the ones place. We have 8 take away 7, and we can do that because the bottom is not bigger, and that's 1. Then we go to the tens place, and the bottom is not bigger, so we can subtract. 6 take away 5 is 1. And then we go to the hundreds place, and in the hundreds place, the bottom is bigger. So I'm going to borrow a cube of 1,000, and I'm going to bring it over. And now I have 13 hundreds, or 13 flats, in the hundreds column. And 13 take away 9 is 4. And 3 take away 0 is 3. So the answer should have been 3,411. The second part on your lesson plan that I've sent to your parents is that you would write numbers that I say, but I'm going to skip that because you guys are generally pretty good with that. So we're going to go to review of rounding dollars to whole cents, to 0 cents. So if we look at this first one, we have 35 cents. And remember, we're wanting to round it to the nearest dollar, so there will be no cents. I have $4, so my range is going to be 4 to 5. I look at 35. 35 comes before 50, so that tells me to round my dollars down. So $4.35 rounded to the nearest dollar would be $4. All right, let's look at the next one. $9.01. Now you do it, make your decision. You know you're rounding to the nearest dollar, so there'll be no change. Your range is going to be $9 to $10. 1 cent would round down, so $9.01 rounded to the nearest dollar is $9. And then we have this last one, $10.79. We're rounding to the nearest dollar, so we don't want any change. We want whole dollar bills. We have 10 here, so our range is 10 to 11. 79 is greater than 50, so 79 rounds up. So $10.79 rounds up to $11. All right, look at this question. I want to know, let me see, I've lost my place. When something is divided into thirds, how many equal parts or sets are there? Thirds tells you 3. Look at this fraction, 1/3. What does the denominator is in the bottom, what does the denominator tell us? Well, it tells us how many equal parts or how many equal sets there are. What does the numerator on top tell us? The numerator tells us how many of those pieces or how many of that set that we're going to get. If I draw a circle and divide it into thirds, what is my addition sentence so that it equals 1 whole? And we talked about this at school. If the numerator is the same as the denominator, it equals 1 whole because I have all the pieces. So each piece of this circle represents 1/3. So if I label that, and then I make that into an addition sentence, 1/3 plus 1/3 plus 1/3, I have 1, 2, 3 pieces out of 3 pieces. Notice that your denominator stays the same. When you add fractions, your denominator stays the same. You didn't divide it into more pieces, you're just counting how many of the total pieces you have. And if we added it up, there are 3 equal pieces. We added 1/3, 1/3, 1/3. We got 3/3. The top is the same as the bottom. When the top is the same as the bottom, it equals 1 whole. Okay? We could do the same thing. I'm just going to throw this out here. If I wanted a math sentence, each of these is a fourth. If I wanted the math sentence to show 1 whole on this circle divided into fourths, I would add each of these pieces, 1/4 plus 1/4 plus 1/4 plus 1/4. I have 1, 2, 3, 4 pieces, and there are 4 pieces total. So 4 out of 4, or 4/4, top is the same as the bottom, means the whole thing. All right, thinking question. Which is greater, 1/2 or 1/3? If I were going to put a mathematical symbol, greater than, comparison symbol, greater than, less than, or equal to, what would my answer be? If you don't know off the top of your head, always draw a model. So if I had a square or a rectangle and I divided it in half, and I had a rectangle and I divided it into thirds, I'm going to straighten that up a little bit. Is 1/2 greater than, less than, or equal to 1/3? Well, the answer is 1/2 is greater than 1/3 if the objects you're comparing are alike. Now, why is that? Remember, it goes back to the denominator. The smaller the denominator, the larger the piece. The smaller the denominator, the smaller the piece. If you're comparing like sizes, if your shapes or your group of objects is the same, anything divided into 2 parts is going to be more than anything divided into 3 parts, because every time you share, again, the amount you get is less. If one of my favorite books to read to talk about division is The Doorbell Rang, and it's about a family who bakes some chocolate chip cookies, and they're going to divide them between the 2 children. Well, then the doorbell rings and a friend comes over, so they divide them between 3 children. And then the doorbell rings and somebody else comes, and they have to divide them between 4 children. And the more times that you have to divide the set, the fewer cookies you're going to get. And that's what happens with division. That's what happens with fractions, because fractions are just another way to say we're dividing objects or groups. Not only can we divide an object into thirds, we can also divide a group of objects into thirds. So I want you to draw on your paper 6 circles. Now this is where it's important that you've been practicing your multiples. You already knew your 2s coming into 3rd grade. You knew your 5s, you knew your 10s. This year we worked on 3s and 4s. Some of you may even know more than that, and that would be awesome if you do. The 11s are easy to learn as well. But we're going to start with a group of 6 circles. And I want to divide these 6 circles into thirds. So we need, if we're going to divide this group of objects into thirds, I want to know what 1/3 of 6 equals. And you are dividing. So what I'm going to do, because my denominator is 3, I'm going to count by 3s until I say 6. So I'm going to put up my fist and I'm going to say 3, 6. Well, how many fingers are up? 2. So that means that I need to circle groups of 2. And that gives me my 3 sets. Well, how many are in each set? 2. So 1/3 of 6 is 2. You have to know your multiples of 3. All right, the next one, let's do another one. Let's do 9 circles. And this time I want to know what 1/3 of 9 equals. Again, my denominator is 3, so I'm making this group into 3 equal groups. So I'm going to count by 3s until I say 9. So here we go. 3, 6, 9. How many fingers are up? 3. So I'm going to circle groups of 3. And when I do that, how many are in each group? 3. So 1/3 of 9 is 3. I have 3 groups, and each group has 3 in it. One of those groups represents 3 circles. Not so hard, is it? And I think we touched on this a little bit before we went home. You could keep doing this and doing it and doing it. If you know your multiples of 3, you're going to be just fine. If it asks you to divide a group in half, if you know your multiples of 2, you're fine. If it says divide it into a fourth and you know your multiples of 4, you're going to be fine, because all fractions are division and counting your multiples. All right, thinking cap. Old Faithful is a geyser in Yellowstone National Park. A geyser is a spring from which a column of hot water and steam shoot. Old Faithful erupts every 50 to 80 minutes. If you watch for 1 hour, what is the most number of times you could possibly see the geyser erupt? Don't get fooled. Some of you are going to think, okay, an hour is 60 minutes, and if it takes 50 minutes, then I can only see it 1 time. You're getting tricked if you think that. If that geyser went off right when you got there, or even 5 minutes after you got there, or even up to 9 minutes after you got there, or 10 minutes after you got there, you could have seen it 1 time in this spot, and then possibly have seen it 1 more time in this spot, because it erupts every 50 to 80 minutes. Some may think we could see it 1 time. However, if the geyser erupts between minutes 1 and 10, it could possibly erupt again before the 60 minutes are up, because 0 plus 50 is 50, 10 plus 50 is 60. So if it erupted here, I know I might could see it again. If it erupted anywhere in this spot, I might could see it again. It's a reasoning problem. What is the least number of times you could see it erupt? If the geyser erupted right before you arrived and did not erupt for more than 60 minutes, you would not see it at all. So if you got here and it had just erupted and it didn't erupt for 60 more minutes, you wouldn't see it at all. Because remember, the time span is 50 to 80. It might erupt in 50 more minutes. It might take it 60 more minutes. It might take it 80 more minutes. You might stand there a whole hour and never see it erupt. But you could possibly see it erupt 2 times. It just depends on what the geyser wants to do and what all the heat underneath the earth wants to do. All right, your job today is just to complete workbook page 308. I'm not asking you to do any more than page 308. There are some questions that your parents or your sister or brother or whatever person is working with you will need to read to you from the lesson plan sheet that I have sent through. For numbers 3 and 4, it tells you in number 3 to color 1/3 of the campers. So you're going to count your multiples of 3. There are 6 campers, so count your multiples of 3 and see how many campers that is. And on number 4, again, you're going to count by 3s until you figure out how many fingers are up when you hit that multiple. You have to know your multiples of 3. If you don't, you might need to write them down to help you count off. All right? This is the last math lesson that I will do with you guys this week. Your 3rd activity for the week will be a speed drill and a math test. And, you know, I love some math. I tried to cut it short. I don't know if I was successful, but practice saying your multiples.